Hello everyone. Today's topic is convolution. So today we will discuss about convolution and its application. The basic meaning of convolution. Convolution means mixing and folding. So convolution is basically folding and mixing of two signals. Convolution can be performed on continuous time signal as well as discrete time signals. For continuous time signals, there are two ways by which convolution can be performed. First is your graphical method, and second one is your transform. For discrete time signals, there are three ways actually by which convolution can be performed. First is your graphical method, second one is your transform, and third one is your matrix method. So first we will discuss about the convolution by graphical method for continuous time signal. So convolution for continuous time signal is referred as convolution integral, given as yt is equal to minus infinity to infinity x tau h t minus tau. So convolution integral we will discuss through an example. Let us take an example of two gate functions with same time duration. And same amplitude. So in convolution by graphical method, first we assume one signal as first signal and other signal as second signal. So first step is to convert the scale. We convert the scale from t to tau. Now second step is assume first signal as x1 tau and second signal as x2 tau. Keep one signal as it is and fold the second signal. So the second step is folding of signal. Keep first signal as it is 0 to 1 tau x1 tau and fold the second signal. Folding means you are making plus tau as minus tau and minus tau as plus tau. Now the third step is the second signal. Keep this signal as it is and shift the second signal left side and also for right side. So first we will shift this signal by an amount t, assuming that t is less than 0. So third step is for t less than 0, shift the second signal. By an amount t, where t is less than 0. Maybe it may be minus 0.5 or minus 0.2. Okay. Now, see the overlapping area between the first signal and the second folded and shifted signal. The overlapping area between x1 tau and x2 tau, that is folded, which may be assumed as x2 t minus tau. So the overlapping area is nil. That means yt is equal to minus infinity to infinity x1 tau x2 t minus tau is equal to 0 for t less than 0. Now the fourth step is at t is equal to 0. This is your x1 tau and this is your x2 minus tau folded signal. Now, the overlapping area between the first signal and the second signal is also nil. So at t is equal to 0, yt is equal to minus infinity to infinity x1 tau x2 t minus tau is equal to 0. So at t is equal to 0 and t less than 0, the overlapping area between the two signal is 0. Hence the resultant signal is equal to 0. Now we will shift the signal for t greater than 0. Now the next condition is assume that t is greater than 0 but it is less than 1. So first signal would be like this 0 to 1 tau x1 tau, and the second signal, that is your folded and shifted signal, would be like this. Now, the overlapping area between the signal 1, that is x1 tau, and the shifted and the folded signal, we can see the overlapping area is between 0 to t, this portion. This portion is overlapped. So yt is equal to minus infinity to infinity x1 tau x2 t minus tau d tau can be written as 0 to t, x1 amplitude is 1, x2 t minus tau amplitude is 1, d tau. So is equal to t. Now the next condition is assume that t is greater than 0 and t is greater than 0 and it is equal to 1. So when t is greater than 0, say it is plus 1 and it is equal to 1, then the first signal would be as it is x1 tau 1 0 1 t, and the folded signal would be like this x2 t minus tau 0 to 1 tau 1. So we can see the maximum overlapping would occur between the two signal. So from 0 to 1, maximum overlapping between the two signal x1 tau and x2 t minus tau. Hence the output yt would be 0 to 1, maximum overlapping will occur. So at t is equal to 1, we will have maximum overlapping. Now the next condition is Assume that t is greater than 1 but it is less than 2. First signal as it is 0 to 1 t x1 tau, and the second signal would be like this. Since t is greater than 1, so this point, and t is less than 2. So we can see the first signal is between 0 to 1. This is our first signal. So overlapped area would be from -1 plus t to 1. So at this point, with this condition, the resulted signal yt would be from -infinity to infinity, x1 tau, x2 t minus tau, d tau would be equal to -1 plus t to 1 into 1 d tau, and it would be equal to tau. So yt would be equal to 2 minus t. Now the next condition is, assume that t is greater than equal to 2. So at t greater than equal to 2, first signal would be from 0 to 1, would be as it is, no change, x1 tau, and the second signal, that is your shifted signal, x2 t minus tau, would be now when we see the overlapping area with this condition, we can see when t is greater than or equal to 2, there is no overlapping area. Hence, with this condition, yt would be equal to 0. So if we keep on moving the signal for t greater than equal to 0, beyond this, the resultant signal yt was equal to 0. So the output signal we will get while convolving x1t and x2t is like this. At 0, we are having 0, yt is 0. At t is equal to 1, we are having maximum overlapping, that is equal to 1. And for t greater than equal to 0 till t is equal to 2, the slope is 2 of minus t. So our resultant signal from 0 to 1, it is like a ramp with an increasing slope, and from 1 to 2 we also have a slope but with a decreasing slope. When the two pulses, that is your gate functions, are of same duration, we always get the triangular shape waveform. The resultant signal would always be triangular, but if the duration of the signal are different, then we always get trapezium. So that should be keep in your mind that when the duration is similar, we will get triangular. For verification of your resultant signal, this concept is very useful, and when the duration of the two pulses are different, we will get trapezium. Resultant signal would be of trapezium shape. Thank you.